Hey guys, and welcome back to our channel. Today, we will be discussing related rates. So, ano nga ba yung related rates? So, yung related rates po is application po siya ng implicit differentiation. So, we have steps here or we have strategies here in solving the related rates problem. First, when we have already the problem stated, yung gagawin natin dito is we will draw the figure of the problem and label all the variables and constant. Yung gagamitin po natin yung t for time and we will assume na lahat ng variables ay differentiable ng function of t or lahat ng variables ay differentiable ng function of time. Second is we will find an equation relating the quantity with the unknown rate of change to quantities whose values of change are known. Yung gagawin natin dito is hahanap tayo ng equation that would fit the problem. For example, if the problem is relating to volume, therefore, we have to look for formulas na under sa volume. For example, we have to look for the volume, the change in volume of a cone, therefore, we have to look for the formula in volume of a cone. Third one is we will differentiate both sides of this equation with respect to time and solve for the derivative that will give the unknown rate of change. Yung gagawin natin dito sa third strategy is we will differentiate the formula na nahanap natin na perfectly fit dun sa problem. Fourth is that we will substitute into the resulting equation all the known variables. Okay? Kasi ginawa natin dito sa strategy 1 is we draw the figure, then we label all the variables and constant. So yung gagawin natin dito sa step 4 is that we will substitute all the labeled variables and constant into our resulting equations. So all known variables and the rate of change. Then we will solve for the required rate of change. So let's apply this into a problem and let's start solving related rates problems. So we have here the first problem. Water runs into a conical tank at the rate of 8 cubic meters per hour. If the height of a cone is 10 meters and the diameter of its opening is 12 meters, how fast is the water level rising when the water is 3 meters deep? So first, we have to draw the figure and label the variables and constant. Sige, let's draw the figure. So we have a conical tank here. So let's draw a conical tank. So this is a conical tank. It says here the diameter of its opening is 12 meters. Therefore, the diameter of its opening, this one, is 12 meters. Next, it runs into a conical tank at the rate of 8 cubic meter per hour. It means this is our change in volume with respect to time. So let's write our givens here. So we have the change in volume with respect to time. That's 8 meter cubic per hour. The height of a cone is 10 meters. The question is, how fast is the water level rising when the water is 3 meters deep? So we have a water here which is 3 meters deep. So this is the height of the water already. That's 3 meters deep. Okay. How fast is the water level rising when the water is 3 meters deep? Therefore, yung hinahanap natin dito is the change in height with respect to time. So we have to identify first our variables and constant that we will be using in solving this problem. So we have here a 12 meters diameter of its opening and we have also a 10 meters height for the cone. And we all know that radius is equals to half of the diameter. Therefore, our radius is equals to 6 meters. And our height is equals to 10 meters. Now, if we are going to observe the figure, we all know that if there is a change in height in our figure, there will also be a change in diameter. Our 6 meters radius is equals to our 10 meters height because the change in our height will also lead to the change in our radius or our diameter. So next is that we will be looking or we have to find an equation that would relate into our problem. For example, in our problem here, is that we have a conical tank. It means that we will be looking for the volume of a cone formula. Okay? Please take note that the volume of a cone is equals to 1/3 times pi times r squared times height. Okay? So our radius here, galing po siya dito. So our radius would be 6 meters times the height divided by 10 meters. And if we're going to simplify this, ang reduce the value, that would be 3h over 5. Okay? So this is the value of our radius. Okay? Let's plug it in here in our equation of volume of a cone. That would be the volume of a cone is equals to 1/3 times pi times 3h divided by 5 raised to the power of 2 times the height. Okay. Next, that would be volume of a cone is equals to 1/3 times pi times 9h squared divided by 25 times h. Okay? And we can separate this. That would be 9 over 25 h squared times h. And we can multiply this in this constant. So that would be the volume of a cone is equals to 3 pi over 25 times h cubed. So this is our equation now. We now go to the third strategy or our third step. We have to differentiate both sides of this equation with respect to time, and we will solve for the derivative that will give the unknown rate of change. That would be the derivative of the volume of a cone, that's dv over dt, is equals to 3 pi over 25. This is multiple constant rule. The constant will remain and we will derive the variable. That would be 3h squared times dh over dt, an implicit differentiation. Okay? This time, we will be isolating our dh over dt because this is the unknown rate of change that we are looking in this problem. So for us to do that is that we will be cross-multiplying this part going to this part. Okay? To isolate the dh over dt. That would be dh over dt is equals to the derivative of the volume with respect to time, with respect to the change of time. So if we're going to scroll up here, we already have the value for our dv over dt. That's 8 meter cubic per hour. So let's rewrite na lang. That's 8 meter cubic per hour times 25 divided by 3 pi multiplied to 3h squared. And please take note here that our h or our height is already in the problem. We have here 3 meters deep. How fast is the water level rising when the water is already 3 meters deep? So therefore, our height here is equals to 3 meters deep or 3 meters. Okay? So let's plug in the value. That would be the change in height of the water with respect to the change in time is equals to 8 cubic meter per hour times 25 divided by 3 pi times 3 times 3 meters raised to the power of 2. Okay? So, iisa-isahin po natin to para mas madali siyang maintindihan. That would be the change in height with respect to time. 8 meter cubic per hour times 25 divided by 3 pi times 3 meters times 3 meters, that would be 9 meters squared times 3, that would be 27 meter squared. Okay? The 3 here is already cancelled, so yung may iwan na lang is meter per hour because we still have the r here. Okay? Meter per hour, please take note of that. Then let's calculate this in our scientific calculator. Therefore, the change in height with respect to time is equals to, so the answer is 0.79 meters per hour. So ngayon nahanap na po natin yung question dito na how fast is the water level rising when the water is at 3 meters deep. So yung speed po ng water is at 0.79 meters per hour. So this is the final answer.